Oh, okay. Good afternoon, all my dear students. Only 60 students are present. So, dear all students, today I didn't have any lecture as per your timetable, but suddenly I got request from Ranjit Kagde sir. He may be busy with his own schedule. So that's what, instead of DS data structure lecture, I will handle a microprocessor lecture instead of data structure. So, and still more number of friends I want to join. Please insist them or call them to join microprocessor lecture. So at 1 or 2, up to 1 or 2 minutes, let's start immediately about my microprocessor lecture. So dear all students, even though still from the yesterday to till I didn't got any questions, it means that uh, I'm happy to microprocessor because all of you are understood very well. You are understanding the subject because no doubts means you are understanding the subject very well. Thank you for that. So please more concentrate on this subject and grasp the subject and do hard work as well as smart work. So still you have any doubts, please I'll give you 5 more minutes. Please discuss with me. Otherwise, I will start microprocessor lecture, whatever I stopped from yesterday's. So please, any questions? Okay, no problem. So only one question I got from one of the student, that is, he or she may facing a problem in the TOSM while she is after pressing F7, he is not go back. So here, I think many of the students are getting problem on this software. Once you go for after the execution, after giving a last command, fourth command, if you are going to execute and press the few tab. In that CPU tab, after you have to started with F7 for line by line execution. Wherever somewhere if you want to got stuck in the TASM, you may not come back. Okay, this is the one problem. Only one question I got from one of the student. So today I will tell you how to solve that. Okay. So apart from that, in the theory lecture, I didn't got any questions about the instructions. So dear all student, whatever 24 instructions yesterday I explained you, very easy and very short. The name itself, it is giving a complete meaning of that instruction. So again, today also for 1 hour, we will talk about lecture about the instructions of third unit. And after first hour, I'll take hardly half an hour for lab session, and I'll clear all the doubts of your TASM software and how to execute, how to use the command, how to type the program, all those things I will explain. Okay. So uh, first I will share my screen. Okay. Yes, fine. So yesterday we talked about all rotate and shift instructions. For rotate instruction 4 and for shift instruction 4. So these instructions we taught yesterday. So dear all students, how many students? 84 students are present. What about others? Still okay, they may join within 1 or 2 minutes. So dear all student, am I audible and my screen is visible to you, please?
Yes, sir.
Yes, sir.
Okay, okay, fine. Okay, dear all students, these are the instructions I have to cover yesterday's about 24 instructions. Please, you have to make a list out one by one and you have to get the meaning of each instructions. At the end of this unit, I also give you all the list of instructions. I will make one list of instructions and complete meaning of particular instructions. That list I already started to prepare, and that one I will transfer you immediately after completion of this unit. Okay, so today I will go to again one more new topic of the instruction that is interrupt control instructions. So again interrupt is comes here. Interrupt means there is a one interrupt flag is also there, and this is the interrupt is nothing but it is the abnormal conditions is going on in the microprocessor execution. And this interrupt complete we will study in the unit of 6. That's what I will not go in depth. But as per the third unit, just we will recall three main interrupt control instructions. Only three interrupt control instructions we are going to study. So what are those three types interrupt control instructions? The first one, अभी interrupt control instruction में अभी three category है. So ये interrupt बोले तो हम क्या बोल सकते हैं? हम how we have to give the definition. There's some abnormal conditions, some abnormal status is going on while executing the microprocessor program. So for avoiding those kind of abnormal conditions and the program is going to be execute smoothly and successfully, for that we have to use three control instructions of interrupt. So first instruction, that is int instruction or int type. Int type is nothing but interrupt type. And the second one is INTO, interrupt on overflow. INT means what? It is an interrupt. Yesterday's in a program, also you have to use it, right? One int 3. Int 3 you are used. Int 3 in the sense what? That is return from ISR. So third one is IRET, that is return from ISR. What is ISR? ISR is nothing but interrupt service routine. Interrupt service routine. So this ISR also we have to use it. So these are the three main categories in the interrupt: int type, int overflow, interrupt on overflow, and interrupt return from ISR. Again, this interrupt return, sub three categories are there: pop, instruction protocol, instruction pointer, and pop code segment, and pop flag register. Again, these are the three subtypes of return from that RET interrupt instruction. So first one we will see that interrupt type. So interrupt type normally we call it as INT. INT. So here in this INT is nothing but what? It is a mnemonics, name of mnemonics, that is interrupt. So this instruction causes an interrupt of a given type, which is the type can be number between 0 to 255. So totally 256 characters. That is 256. 0 to 255 means 256. In that any abnormal things are going to be happened, we are going to solve by use the interrupt instruction. And there is some actions we have to use it for the interrupt the type, that is in the push flag register onto stack. So whenever we are going to push a flag register into the stack, and the stack pointer which is decremented by 2, that time we are going to be use the enter, because directly we are going to be decremented by 2. It means that one step you have to decrement by 1, and in another step you are going to be decremented by 1. So one decrement plus one decrement, total it is a 2 decrement, that is a SP minus 2 decrement. And one more, you find that is interrupt flags and trap flags are cleared. Interrupt flags and trap flags. Yesterday also you have to saw that trap flag. Trap flag is used for the to perform a single step for one, and to perform no step for zero. That is interrupt flag and trap flag are cleared here. So here, and one more, that is push code segment onto the stack. One is for the flag register, and another is for the code segment onto the stack, and stack pointer again decremented by 2. And in the fourth one, that is push instruction pointer into the stack, again decremented by 2, and a new value taken from the location of type 4 of the internet instruction pointer. So here, for example, if we have to use it int 1, the meaning of int 1 is nothing but the instruction pointer. It may be a four address, that is 000 memory location 0004 and 0005. So in that we have to use the int 1, and for the int 2 also we have to use it, int 3 also we have to use it. So for the new value of port segment taken from the location of type 4 interrupts, that time we are going to be incremented by 2, so it is a plus 2. And the int 1, that is a code segment for also 5 to 7, again here it is using a 2 more bits. So for the execution of interrupt service routine, that begins from the address formed by new values of code segment and instruction pointer, that is CS and the instruction pointer IP. So this is about the interrupt. So int 1 also you have to use it, int 2 also you have to use it, int 3 also use it, int up to int 21. In the program you will see that up to interrupt 21 types you are going to be studying. Okay, so this is about, that is a interrupt instruction. So next one is interrupt with the overflow. Whenever overflow is occurs, whenever the stack is full, again you are going to add some values or a information or a data to the stack. That time, to excess of the size of the stack, it happens overflow, that is interrupt on overflow. In the interrupt, so the interrupt is going to be handle the conditions. That time more number of conditions are over, number of conditions are got in the interrupt, that is interrupt on overflow instructions. So in this instruction, it causes an interrupt of type 4. So interrupt, all totally 7 types are there. All types you studied in unit number 6. Just you remember that the instruction causes an interrupt type of 4 only, and because it only the overflow condition, overflow flag is set to the at the type of 4 in the data. So for that, the interrupt on overflow type 4 only used in the overflow flag set for set and reset purpose. So here the one more sequence of followed and the control transferred to the location pointed by 001H. Here I have to mention that 001H, but any number of memory locations you have to take, and for that sequence is going to be continue with further onwards 10111 like this. Okay, so that is interrupt overflow. When we have to use this interrupt overflow flag, whenever the interrupt is already going to be filled, again overloaded, again you have to load it on the interrupt that time it was happened, interrupt overflow. So next, the third type, that is return from ISR. So in once any abnormal conditions are occurred and you are going to be solved by these two types of interrupt and interrupt overflow, that time you are getting a result. That result is going to be print on the console. So for that you have to use it return from ISR. Compulsory you have to use interrupt service routine. From that interrupt service routine you are going to be print this value or output. So again in this there are three types. One is pop with the instruction pointer and pop with the control segment, uh, code segment, and pop flag register. So this pop instruction pointer from the stack, always it is decremented by 2. And in the code segment also again it is decremented by 2. So wherever the stack is comes, in the stacks always it is going to be decremented by 2. That is stack pointer. So here in the flag register from the stack, the stack is decremented by 2 again. So in the return from ISR for decremented by 2, because the stack condition always we have to check it with decremented by 2 or stack pointer minus 2. So for that all stack decremented by 2 as sp minus 2 we have to use it with pop instruction pointer, pop code segment, and pop flag register at the last one. So these three are, so these are not many times we are using because almost there is no any abnormal conditions are occurred in the program. Very rare condition the abnormalities occurred, that time we have to use it, these three interrupt instruction, interrupt control instructions. Okay, so again these three instructions you have to remember. So after this I have to use, uh, again next subheading of instructions, that is explain string instructions of 8086. So what are the different types of string instructions used in 8086? So again there are uh, 15 instructions, 15 instructions we have to use it for string operations, string particular string related instructions in the 8086. What are those are I have to listed here. Please you have to check it out the list. So in totally 5 columns and 3 rows. So out of 5 columns and each one having a two 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 two. Okay, moves, that is move instruction. Move s in the sense what, move string. First one is a move string which is having again two types, move b and move sw, we will see later. And the second one, that is loads, to load the string, loads in the sense to load the string, that is load again b and sw. So and the third one, to store, sto in the sense what, it is a store, s is string, store string. And the fourth one, that is cmps, it means that compare, cmp means compare, s means string, compare string. And the last, that is the fifth one, SCA, scan. Scan, S in the sense what? Scan the string. So there are totally 5 main types. Move string, first one. Second one, loads string. Third one, stores string. Fourth one, compare string. And the fifth one, scan string. So out of these five, again having a two types, that all types we will see now in detail. So listen, dear students. So first one, I will take string instruction, that is move string instructions. So already move instructions you used many aspects in many examples. Even lab session first program also you have to observe move MOV. Move instruction is what? It will transfer source to the destination. Whatever the data is present in the source register, that data is going to be transferred it into destination register. That's what we have to use the move destination comma source always. So the same concept you have to apply with the string, that string instruction. So in the string instruction, a series of bytes stored in sequentially in the memory, and the string instructions operates on such as strings. So here for the source string is at a location printed by that source index. Their source string is located at source index, and in data segment which is to be present in the data segment. For that you have to transfer to the destination string, source to the destination. Here it is a location pointed by a destination index. So whenever the data is present at the source, you say you call it as a source index, and that data from here you are going to be sent, you are going to be transferred. So that location you call it as destination, and that point you say it is a destination index. So in also you have to use some extra segment in the destination purpose. So here the count of string operations is always given by the C register, because normally we have to use the C register for the string operations. Sometimes you may use B register also, D register also, not a problem. So in a normal usage, you have to use C register for the string operations. And also we have to use CX. CX in the sense what? It is a 16-bit. So 16-bit register we can transfer maximum of 64 kilobytes using the string instructions. That is possibility. So and the source index and the destination index, SI and DI, source index and the destination index is incremented or decremented by 2 after each operation depending upon the direction flag. So as for the based on direction flag, we have to decremented or incremented by 2. Either it may be a source index or it may be a destination index, or sometimes both at a time you are going to be decremented or incremented by the help of direction flags. So here if the direction flag is 0, what it means? It is auto increment with the clear direction, CLD. Yesterday you studied this instruction, that is clear direction instruction is used. And if the direction flag is 1, it means that it is again auto decremented, that is STD, set direction instruction is used. So clear direction and set direction you have to use it in the string instructions. So now we will go to one by one instruction. At the first one, move instruction. In the move, either we have to use move B or move SB or move SW. So here move S is a normal, which is a move string. Either it may be a move string with the byte or with the word. So there are two types. Again, either you are going to be use byte or you are going to be use word. Move SB in the sense move string byte or move string word. Move SW. Okay. So here in the first type, now we are going to be this one. First type, move string, it is used to transfer a word or a byte. That's what we have to indicate, either B or W. We have to use it to move or to transfer a word byte from data segment to the extra segment. From the data segment to the extra segment, we have to use this instruction. And also the offset of the source in data segment is in the destination index, and the offset of the destination in extra segment is in the destination index. Okay, so here the source index and the destination index are decremented or incremented. These are going to be as per our convenient operations, needful operations. We are going to be decremented or incremented depending upon the direction flag. Either direction flag says it is a 1 or 0. Based on that, these operations is going to be carried. So for this move string instructions for the byte I have to given one example is here, that is extra segment es with a destination index. How that destination, whatever the source index data is there, that one is going to be transferred it into destination data segment, and that data segment with the extra segment is added. So finally you are going to be si plus 1 and di plus 1 plus or minus 1. It may be a plus or minus 1. Why I have to use it plus or minus? It may be a increment or it may be a decrement as per our requirement operations. So that's what in a single line only I have to use it either plus or minus, increment or decrement, source index with 1 and destination index with 1. Depending upon the direction flag, it will work. Same thing as per the move string byte. Move string word is also operated, but it is a 16 bit, which we can use same instructions here, but si plus 1 with the data segment and si with the data segment. One more extra we have to use it because of word is 16 bit, byte is 8 bit. One byte is equal to 8 bit. One word is equal to 16 bit or 2 bytes we have to say. That's what, instead of here plus or minus 1 in the byte, I have to use it plus or minus 2 in the word. That is move instruction, move string word. In that double of this move SB. That's what we have to use it. So this is used for move string. So next one, the second type of string instruction, that is loads in the sense what, load string, that is load string. So in the load string again, load string with the byte or load string with the word. B is for byte and W is for word. So LOAD, it is a mnemonic, is called as an instruction. That is name of the instruction is load string byte or load string word. That loading the string purpose we are using this instruction. So it is also same as your previous one, move string. So move string, what you will do, you just transfer from one place to another place. But in the loads, what it will do, you have to loads. If already if the data is there, again data you are loaded into that same register, that time you have to use the instruction load, that is load string byte or load string word. So in this it is used to load a byte or a word to AL register or AX. AL is for 8 bit and AX is for 16 bit register from data segment, and the offset of the source in the data segment is in source index as we know already, and also the source index we are going to be incremented or we are going to be decremented depending upon the direction flag. So in this example, as per move instruction, loads SB in the sense what, you have to load the whatever containing the source index data into the data segment, and from that data segment to 8-bit A register. You say sometimes as accumulator also. Same here you have to do it plus or minus 1 with the source index at the time of byte. So at the time of word in the second example, you just going to plus or minus 2 because it is double of byte. Word is nothing but double of bytes. So for that, you have to use the load string. So next, the third one in the string category, that is stores. So what is stores? What is difference between load and store? So store means what? Just you have to keep the data in a particular register. But loads means you have to put data on data. That is a load. So here in the stores string, again here in this two types, stores string byte as well as store string word. So for byte 8-bit again, for word 16-bit again. So it is used to store, that is AL or AX into the byte or a word into the extra segment, that is used for previous one you are going to use the quotes segment, but here you have to use the extra segment for the stores string. So the offset of the destination in extra segment is in the destination index, and for that destination index you are going to be incremented or you are going to be decremented depending on the direction flag. So for that, STOSB and STOSW is used for direction, that is destination index to extra segment, because we have to use it here extra segment, and in the word that is plus or minus 2 with the destination index to destination index, that is with a double of bytes. So it is about just for stores string purpose we have to use. And that fourth one is a compare string. So if we are going to be compare with the source string and the destination string, that time we have to use CMPS instruction, is nothing but compare string byte or compare string word. Comparing a string of byte or a word, we have to use CMPS instruction. So it is used to compare a byte or a word in a data segment with the byte or a word in the extra segment also. So this compare also we have to use extra segment, and for the offset of a byte in this data segment is source index, and the offset byte for the word in extra segment is destination index, source index and destination index. But here in the source and destination it may be increment or decrement, depends upon the direction flag, and we are going to be comparison is done by the subtracting a byte or from extra segment from the byte or the word from data segments. So here commonly you have to use data segment, code segment, and extra segment. We are going to be used it here. So for that, this is the compare SB. So we are going to be compare source index plus or minus 1 to source index, that is in the byte, and we are going to be plus or minus 2 as a decrement or incremented by 2 in the word comparison, that is compare string word and compare string bytes. So these two conditions you are going to be checked with the string compare, uh, string compare or comparing a string, that is compare string byte and compare string word. So these fourth category. And at the last one, fifth category of the string, that is scan. SCAS, in the sense what? Scan string. Again, two types here also. One is for byte and one is for word. So it is used to compare the contents of 8 register or 16-bit AX register with a byte or a word in the extra segment. So the offset of the byte or a word in extra segment is that is 16 in the destination index, for the word 16, and for byte it is 8 in the destination index. And the destination index is incremented or decremented by 1 or 2 based on that 8 bit and 16 bit, and the direction flag is going to be affected by the either 0 DF or 1 DF. 0 means 0 flag for direction flag, and 1 means 1 for direction flag. Based on that, you are going to be either incremented 8 bits for byte and decremented 16 bits for word. And we are going to be comparison is done with the subtracting by a byte or a word from the extra segment from AL or AX register. So the flag bits are affected, but the result is not stored anywhere. So in the scan means what? We are not going to be store the data, just we are going to be read the data. Scan means we are going to be read the data, either byte or a word, we are going to be read it. So these all four types, that is scan B and scan W. We are scan B in the sense what? SCAS, scan string byte and scan string word. These two we have to use to reading the string, either it may be a 8 bit or a 16 bit. So either we are going to be incremented or decremented based on our requirement operations. So this is all about string instruction. So one more is comes, that is uh, repeat, that repeat prefix used for string instruction. So sometimes we are going to be repeat the string, that time repeat prefix used for string instruction we have to use it. So in this an instruction prefix which can be used in the string instructions, repeat. So it can be used with the string instructions only. Repeat wherever you have to use it in the microprocessor, that is used along with string only with the string is possible. So and also it causes the instructions to repeat it cx number of times, that is c is the register, how whatever the data is containing a c register with a 16 bit, that number of times is going to be instructed to the string. After each execution, the source index and the destination index registers are either decremented or incremented based on the direction flag, and the CX register is going to be decremented only. CX is always decremented only. So the CX must be initialized to the count value based on that. For example, if move CX 0023, that 0023 is the memory locations which is allocated by the C register, that is going to be moved into the C register, and we have to clear. CLD means what? Clear data, that clear the direction data. So we have to use. After this, repeat again, we are going to be repeated. That time what you will do, repeat. This way we have to use the repeat instruction. Repeat move string byte. Same way for the word you have to use repeat move string word. So the above section of the program will cause the following string operations, which is the source index and the destination index. So first one, the source index is transported into a data segment, and from that data segment to a destination index it is transferred, and from the destination index to the extra segment the data is going to be transferred. So for that, either increment or decrement for the bytes only one time. So si plus 1 or di plus 1 we have to mention. Same way in the C registers also you have to mention with the minus 1 decrement. So it to be executed 23h times in the auto incrementing mode. So in this you have to use it either 21 or 23, either 1 or 3 you have to use it in decimal, and 21 or 23 you have to use it in hexadecimal values. So next one is, that is repeat on 0 and equal. Repeat on 0 and equal. So here in this condition, so here in this the condition repeat instruction prefix, and it behaves the same as a repeat instruction provided the zero flag set. Either it may be a zero flag in the sense that ZF is one, then it is going to be repeat. Otherwise, no repetition. ZF is zero. Zero flag is zero means no repetition is going to be happen, and it is used with the comparison string instructions. Okay. So again, we have to use it repeat non-zero, and Z means repeat zero or repeat equal E, and here repeat on non-zero and repeat on non-equal or EPNZ, repeat on non-zero, and REPNE, repeat on not equal. So clearly I have to mention here. So it is conditional repeat instruction prefix, and it behaves same as a repeat instruction provided the zero flag is set and reset for the ZF flag is zero, and it is used with scan string instruction. It is used with scan string instructions. So these 7 instructions, extra 2 more I have to add it, that repeat and repeat with zero and equal and repeat with non-zero and non-equal. Along with string 5 instructions, these 3 I have to add it. So enter this string instruction totally 8 instructions are there in that. Repeat one you have to add it, and again in that repeat you have to use it repeat on zero and repeat on non-zero. So totally 7 instructions I have to, so 6 instructions I have to explain in the string instructions. So today whatever I have to cover in the string instructions, there are 6 instructions: move s, load s, store s, CMPS, scan S, and repeat. Totally 6 instructions in the string instruction and 3 instructions in the interrupt instructions. So totally 6 plus 3, 9 instructions I have to cover today. So all 9 instructions, just you have to go and study very well. Very simple, very easiest one, whatever today I have to cover. So after that, so today 9 instructions and yesterday 24 instructions. Totally 9 plus 24, 33 instructions I have to taught yesterday's and today. And before lectures, I have to taught 20 instructions. So 34 plus 20, totally it is 54 instructions I have to taught till now. Totally 24 instructions I have to taught till now. So please, all of you have to go with that. So next, I will take one instruction format of 8086. So after studying, so again, still some more instructions are there, that arithmetic instructions and arithmetic instructions is there, and some of uh, decimal adjustment instructions, arithmetic instruction, decimal adjust instructions, and one more instruction, that is logical instructions. So only remaining 3 instructions are pending. Is the third in it: arithmetic instruction, logical instruction, and decimal adjust instructions. So these 3 instructions I will taught in next class. In the next lecture means my tomorrow's lecture. So I have to complete this unit number third in tomorrow's lecture. So in tomorrow lecture, I have to taught, that is logical instruction. I have to taught. I want to taught in tomorrow, and decimal adjust instructions I want to taught. That is decimal adjust instructions, and arithmetic instructions. So arithmetic instructions. These instructions I am going to taught in tomorrow's lecture. So in my regular lecture, I have to taught. So once we taught these 3 instructions, it means that complete of that third model is over. So here, after today's 9 instructions, whatever I explained you, so after that there is a one heading, that is instruction format of 8086. That is nothing but what is instruction format. So the instruction format of 8086 is totally a 1 2 3 4 5 6, 6 into 4, that is. So here, see, all of you look into my screen. That is, it is a instruction set of 8086. At the beginning, 8 bits is reserved for the upcode. 8 bits is reserved for the upcode, and 6 bit is reserved for the upcode, and 1 bit is reserved for the data, and one more byte is reserved for the word, and 2 bit is used for the mod, and 3 bits are used for the register, and again 3 bits are used for read all memory, write all memory, and one more, that is low displacement data for 1 byte, and high displacement data for one more byte, low data 1 byte, and high data 1 byte. So this is entire format of 8086. Whatever instructions of 8086 you are going to use, that is using this much of memory for storage: 1 byte for high data, 1 byte for low data, and 1 byte for high displacement, 1 byte for low displacement, and entire 1 byte for modulation, register, and read and write memory, and 2 bits for data and word, and 6 bits for upcode. So entire this memory format is 8086 in the instruction. So here, that is upcode. So what is upcode? The upcode is nothing but it is a 6-bit upcode, indicates operations. It is a indicates the operations, and the D is nothing but what? It's a direction bit. D is a direction bit. 1 is for data move and 0 is for data move from operand specified to the register. So if the direction bit is 1, the data moves from operand specified with the read or write memory to the operand specified by register. If it is 0, then the data is moved from operand specified register to operand specified by read and write. 0 and 1. So next one, that is W. Here the W in the sense what? It's a word. So if data is a word, then it is 16 bit. If data is a byte, then it is a 8 bits. For word it is 16 bit. For byte it is a 8 bit. So and second one, addressing mode type. So this is the addressing mode. Mode is nothing but what? It's addressing mode. So in that addressing mode, again it is a 2 bytes. This is a 2 bytes as I mentioned here. 2 bytes. So in that addressing mode, these are called mode bits and decides how it is a read or write or the memory is interrupted. So mode 00011011. So memory is operand, no displacement. If mode is 00, no displacement. Mode is 01, it is a 8-bit displacement. Mode is 10, then it is a 16-bit displacement. And if both mode is 11 or high, then we have to say it is a register operand. First three are memory operand with no displacement, with 8-bit displacement, and with 16-bit displacement. And the last one is 11 register operand. That is a register operand. The last one. So next, that is register up to mode. Next one is a register. In that register, uh, this specifies a register is used as first operand, which may act as source or a destination depending upon the D-bit direction. Either D-bit direction, it may be a source or a destination based on word and byte. So if the register is 3 bits, as we have to take it in the 3 bits, register is 3 bits. So 3 inputs we have to take 000 to 111. So for the W equal to 0 and for W equal to 1, word is 0 and word is 1. If it is 0, we have to use 8 bit. If it is 1, we have to use 16 bit. That's it. Okay. So for read and write 3 bits, next one is read and write. So this one, next one, this is also 3 bits, read and write. So here this specifies second operand which may either be a register, R means register, or M means memory. Register or memory location depending upon the mod bit. So here the register or memory based on 3 bits, we have to use it either it's a register or it is a memory based on that different input operations, register or memory. So for that W word is 0 and word is 1. Word is 0 is for 8 bits and word is 1 for 16 bit. We are going to be used in the different either 00011011 for mod, and these are the register or memory as per in the tables. Okay, so this is about how we are going to be using the format of 8086. So dear all students, today I have to explain you clear 9 instructions, 3 instructions for interrupts and 6 instructions for string. So just all those instructions you just carry and go do the study. So if any doubts from these instructions, again you have to come and ask me. Okay. So again, remaining, as I said now, remaining 3 main instructions, 3 sub main instructions are there. That is arithmetic instruction and decimal adjust instruction, and the last one is logical instructions. So only 3 remaining instructions. One whole lecture I need for explanation. So those are 3 instructions I am going to explain you in my next lecture. Okay. So this much is enough for today's lecture. Now I will go to lab session. Only I will go to lab session whatever the yesterday some students have doubts. Okay, dear students, I will give you 5 minute time. Just I will give you 5 minute time. So already I shared my notes with you. As per my notes, you have to scan. You have to read well all 9 instructions, whatever I explained today. If any doubts, you have to discuss. So for that, take 5 minutes time and you have to read it well. All 9 instructions. Okay. So immediately now it is 1:06. I will start my lab session at 1:12. 1:12. I'll start my lab session. Please, all of you, read these instructions. Okay. Yes. Omkar Kumbar, what is your roll number? Omkar Kumbar. Only your name is there. You have to mention with your roll number with a division. See, if you are not mentioning roll number, sometimes you may loss of attendance. because as per by seeing roll numbers we have to give you a attendance, right? If you are not mentioning roll number only, you may lose your attendance. We are not responsible for that. Onkar Kumbal, okay, change your name with your roll number. uh, okay, fine. Dear students, next we will move to lab session. So yesterday I got one question from the lab session. After pressing F7, after executing line by line, your cursor will not come back, right? So that is one question I have to. So just I will show you that. So here in this, there is a one question from your student. Okay. So dear all students, now we will start with lab session. Okay. What is that question I got yesterday? Uh, okay, here. Yes, okay. So this is the one question. Uh, I am getting problem in the Tasm software. Once I press F7 or any other options, uh, after that I can't do anything. Even I can't go back to comment section. What should I do? Everyone overcome this problem. So dear students, that time what you will do? Just you go to the file. In that file you have to click. You will get a exit tab in the file at the last. You have to click on that file. You select exit. Again you have to start with beginning. In this way you have to getting. Otherwise you are just use escape button in your laptop or in the on the keyboard. Just you have to use the escape button. You have to either go back or you have to do the different activities with that. Okay, so I'll show you now. I'll show you now. So only one question I got from yesterday. So apart from this, any questions, please, any of the other students, please message me any other questions if you are facing any problems with the TOSM software. Okay. Okay, fine. So anyhow, if you have any doubts, please text me a message. Either it may be in WhatsApp or it's maybe in text message, no problem. So now I will move to the lab session, that is TOSM software. Okay. So dear all students, come to the desktop, use the TOSM software. So here I will double click on this TOSM software. Again, same session, I will explain you whatever yesterday I have to conduct. Okay, so because once you have to perfect with the TOSM software, at least one program you successfully executed, then it is too much easy for next program onwards. So for that, basic things you have to be perfect at beginningly. Okay, so dear all student, this is the command window. Once you have to double click on the TOSM software, this command window is opening. So in that command window, four commands you have to use. First command is to opening a edit file. For that you have to use edit, command edit space file name, that is name of the file is add, with a dot extension you have to use TOSM, sorry, that is ASM. So edit file name dot asm. That is the first command you have to use. So in this first command, you are opening this window, that is a program typing window you have to open. So in that program typing window, you have to use for, because your compiler will not understand the human being's language, right? So what you will do, what we will do, we have to understand the compiler by using our own uh, code, program code, or our own instructions. By using the instructions, we have to instruct to the compiler, oh, this is means what? I think you have to assume. We have to say to the compiler, assume. A compiler, you have to assume CS means code, that is code segment, and DS means data, that is data segment. As in the architecture of 8086, we have to use code segment, data segment, stack segment, and extra segment, right? So all these, and then basically just you have to start practice with code segment and data segment. So this entire part at the beginning I have to use it for data segment, and rest of the part I have to use it for code segment. So here code segment is started at this point, like your main function in the C programming. After that, you have to ends, compulsory you have to ends the code, because you have to say to the compiler only from here to here, this is the area of code segment. That memory you are going to be used for the code segment, and this memory, that is this much memory, you have to use it for data segment. So it means that by human being going to be instruct to the compiler, this is the area of data segment and this is the area of code segment. And at the end, you have to ends with data and ends with code. So in the code, you are using the starting point. So and here for end starting point also you have to mention here. This is entire simple program of addition of two numbers, addition of two numbers. So here I will explain you clearly this program. So actually this is the first program as per your syllabus, first program as per your syllabus, to add two 16-bit number, add two 16-bit number. So here I have to use one 16-bit number, 1191H. Just in the sense what? 16 are hexadecimal. Hexadecimal is nothing but what? 16-bit number. So here 1191 for A register I have to use it, and 2272 for B register I have to use it. So all these adding, after adding, whatever we are getting a result, that result we are going to be stored in the sum variable, that is SUM, user defined variable, sum variable. A is already built in, that's a register. B is also a built-in, that is a register. A and B we are going to be use it, and we have to define one summary variable. For that summary variable, we are store the result, that is data segment. So in this what we will do, whatever we have to data is entered from the data segment, that one we are going to be insist to the AX register. So after that the AX register is reserved for the data, whatever we have to assign it in the data segment, and that data segment store we have to transfer this to, transferred from the data segment, that is DS, AX to DS. So after that we have to allocate to a memory location to the AX register. As per my convenience, I have to use 4C00H, but as per your convenience, any memory locations you have to use it. Either 1000, you use it, 2000, you use it, 4000, any number of as your interest, you have to use it for the memory locations of AX register. So after that, whatever the A register is containing a value, that one you transport it into AX register, and B containing a value, that one you are going to be transported into BX register. And the finally, what is our aim? The addition of these two numbers, A and B. A is with AX and B is with BX now. So AX and BX you have to add with the add instruction. See here, this add instruction is nothing but it is arithmetic operations. As now only I said you in theory lecture, add instruction is a arithmetic instruction. That one we will study in tomorrow. All addition, subtraction, multiplication, division we will study. So that is arithmetic instructions. After that, we have to we have to use the sum variable, right? So that AX and BX you have to add it, and that result is stored in the AX register. From that AX register to we have to store in our declared variable sum. So AX to sum, move sum AX in the sense what AX to sum you have to transfer. So here I have to use it int 3. So this is nothing but what interrupt type. Today only I have to explain to you interrupt type 3 we are going to be used. Either one you use, two you use, three you use. Better option you have to use 3 and 21. Later on I'll tell you. Okay. So this is the interrupt. So once this entire program is completed, after that we will end with the code segment. That is code segment ends, and end with the start that you are going to be ends the start. So this is the program, very simple, and this is the first program of your lab session. So go and open your syllabus copy. In that syllabus copy there is the first program in the lab session, that is addition of two 16-bit number. Addition of two 16-bit number. This is the program for addition of two 16-bit number. So dear all students, what you will do after that, go to file, save the program. Once you have to type it, you have to save the program always. After that, you go and exit this edit window. So please all of you carefully listen here, observe here. If I have to press exit, this editable window is going to be exited, and we will reach to command window. Okay, so now that command window is open. So in that command you have to give second command. So please can you tell me anyone what is second command? So the second command is tasm file name, tasm file name add dot asm, tasm file name dot asm. So by this you are going to check any error message or warning messages. So here no error message, no warning message, both are none in the sense zero error and zero warning. So our program is logically and syntactically both are correct. So next we will go to the third command for t-link, which is the objective file, that is t-link file name dot objective file obj, t-link file name dot objective. So that object is going to be mapped with stack. So in that no stack you have to getting by the third command. And by the fourth command, what is fourth command? td file name dot exe. Dot exe means what? It is a executable file. So what is executable file? Name of the file is add with the t link td, that you have to use it. So here you have to again press enter. This window is opening. See, yesterday's what you asking a question, so how you come back. So here carefully observe, just by the mouse you have to click OK. This window is opening. In this window you have to check previously all the registers initially it is 00. So in your program we have to use it only AX and BX register. So here you have to carefully listen, go to file. If anywhere you are getting a struck in this, go to file, just quit it. Go to file and use the quit. You will go to command line, command window. Okay. So please, who are asking this question yesterday and who are having a doubts, go to file. In this observe in the window, go to file, and you have to click on quit. You will go to the command window. Otherwise, you have to execute it carefully. Go to view, So in this view, you have to click CPU. Under the view tab, you have to click CPU. After clicking CPU, you have to press F7. F7 is for step-by-step execution and F9 is for one-time execution. But instead of pressing F9, you have to press F7 line by line. So here I have to press F7. You have to check AX register. So once I have to press F9, F7, here AX register is got a memory allocation, that is 48A D. After that, you again press the F7. So AX is started with 4C00. So that 4C00 is accumulated with the AX registers. Please observe in the windows how the AX and BX values are changing. After that, you have to allocate it that AX is with a 000 started point. Again, you have to press F7, that AX, whatever you have to assign the value 11121, that is going to be added in the AS. After that, again you have to press the F7, you will get a BX value. So in the BX value, again you have to getting 2272. These two values you have to transfer from data segment. Please remember, from the data segment, these two values you are transferred. So at the next instruction, what we say, we have to add AX and BX. We have to add AX and BX. After adding, that value is stored in the AX. That value is stored in the AX. So I'll press the F7. Please all of you observe. So that AX value is getting the result of 3403. The addition of 2272 and 1191 is nothing but 34 uh, 3403. You go and check it out with the calculator, hexadecimal addition. Okay, so this result, after that, it is going to be stored in the sum variable, and from the sum variable, that value is going to be displayed. Okay, so this is the int03 interrupt. So again at the end it will checks any interrupts is happened or not. So if there is no any interrupts, that is IP4 is 14. It started with the 14. So this much is the program. So after completion of this execution, after getting the output here, you just go to the file and click quit. After click quit, you will come to the command window. From the command window, you have to use the command exit. From the command window, you have to use the command exit. Then that TASM software is going to be exited. Okay, this is the final step for the TASM software. So today again same things I repeated, whatever I taught. Okay, and this is the first program as per your prescribed university syllabus. This is the first program. So next tomorrow, in tomorrow, I have to cover three more instructions. Those are arithmetic instruction, decimal adjust instruction, and logical instruction. Along with that, addition of 32-bit numbers I have to take. One program for addition of 32-bit, and these three instructions I will complete it in tomorrow's lecture. Almost in tomorrow lecture, I have to complete your third unit. Please all of you go through with the syllabus and go through with the notes, whatever I shared with you. Please you have to cross check and study well. Okay, so dear all students, this much is enough for today's I have to explain to you just 9 instructions and this TASM software. So all of you be practice more and more practice with this TASM software and be perfect with that. Okay, so I'll stop it here my today's class. I'll take attendance. Please all of you give your attendance, mention your attendance by your comment. Please all of you start to do the attendance. Okay, thank you one and all. Again, we will see in my next lecture.